So hello, today we've finished with our fundamentals part and we're going to start talking about applications. We're going to first make an intro about network applications in general in Node, and then we're going to go to web applications, and we're going to see two of the ways that web applications can be written. Because I can write things which are, let's call them classic web applications, right? So in a traditional fashion, and we can write half of SPAs, right, in Node. But first, let's talk about network applications for a bit. So if we talk about web applications are a subset of network applications, and if we talk about programming network applications, we in any language we generally talk about socket programming. Now we're not going to go too deep into this. This is something that's going to be covered in your networks course next semester. Um, but when we talk about writing such applications which have network communication in any fashion, we generally talk about socket programming. Now, what a socket is a programmable port. So let's take a step back, and if we think about transmitting information in the network, first of all, we're going to need some addresses, right? We need to be able to get some data from a source computer to a destination computer, and then to get the answer to whatever the source computer requested back to it. Now, addresses are going to cover, they're going to be hierarchical addresses, and they're going to cover this mechanism, which just gets a packet of data from the source to the destination. Now, once the data gets to the destination, what's going to happen is the destination computer is not going to know what to do with it unless it has something to identify a particular application which uses network communication. And this is where ports come in. We've already talked about this somewhat. So a port is going to identify one application on a particular computer. And I can only have one application on one port, because if I could have more than one application on one port, I'd need another addressing scheme, right, to identify which application receives a certain packet of data. Um, that being said, when I want to program a network application, what I'm going to have is this programming interface to a port, which is called the socket. Now there are a bunch of challenges here. We're just going to briefly go through them, but these stem from the fact that most networks, or many network operations, are blocking, right? Which means they're just we could express them as wait for something, right? Wait for something to happen, wait for somebody to connect, wait for somebody to send something. I'm going to pause and take a question. Right, so the challenge for network applications is generally the fact that they have a lot of blocking operations, and I have to have one of a series of approaches to handle this, because if I have a blocking operation, what that means is that the server code is going to have to wait for something, right? Which means it can only handle one client at a time. Now, a solution to this, the typical solution to this is to use threads or any other kind of separate execution entity. If you look at Java or C Sharp, you're going to have threads or thread-like things. Um, Now, the second way of looking at this is to put it in a different way to look at it in a different fashion. And this is what happens in Node. Node was actually written to be able to handle this sort of networked application which has a large number of clients. So first, let's see one of these network applications in Node and see how it would be built. Now we're going to build the simplest one, which is a chat server. Okay, and we're going to go through it step by step. This is, however, a low abstraction level, and for web applications, it would add too much noise. So we're going to need something which abstracts a bunch of these things and gives us a simpler way of working with web applications specifically, and with RESTful services specifically, actually. But we'll get to that. So first things first, let's make our little chat server. So in order to make our chat server, we're going to use a package which was included in so it's a library which was included when we installed the Node interpreter, and it's called net. Now, in order to create a server with net, we're going to just create it with net create server. And the server has to do port binding. So it has to bind itself to a port and listen to that port. So I'm going to say server.listen on some port. Now, the way that Node looks at this is we're going to respond to a series of events because, like I said, both in the browser and on the server, Node is constructed around an event bus. So the way to handle an event is going to be really similar. Just let's say the words are going to be different. So we can say server.on event, and the event that we're interested in is on connection. Now this is going to be handled by a function which is a function of client. And once the client is connected, and only once the client is connected, we're going to be interested in a couple of events. So the first thing that might happen is that the client might send some data. So function of data. And the second thing that might happen is the client might disconnect. Now, the logic behind the chat server is we receive a message from a client and we send it to all other clients. So we need to have a list of clients. So let's just have a list of clients. It's going to be this. Whenever somebody connects, we're going to write a nice little message to them. And then we're going to add them to the list of clients. Now, something to notice here is that this server actually handles sending things over a text protocol. Now, we're not going to process the data in any fashion. However, if we'd like to complicate our server, it would be trivial to add a protocol which does something, whatever it is, and then sends the result of this processing to the other clients. So whenever we have data, what we're going to do is we're going to iterate through the list of clients. And if it's not us, we're going to send them the data, right? So if clients of I is not our client, now we also have to handle the end event, which is going to be a client disconnecting, because if a disconnected client is still in our clients array, what's going to happen is when we try to write to them, we're going to basically write on a closed stream, and that's going to give us an exception. So we either have to handle that exception or just handle this event. So when we get the end event, what we're going to do is we're going to say index is clients dot find index, and we're going to say e equals client, and then we're going to do clients dot shift dot splice, sorry, from index 1 position. Right, so we can run our server from a console. Let's just get to our directory again. And in order to test it, we're going to need some clients. Where do we get our clients from? Well, we can actually use something which is included in Linux, which is netcat, so NC, and which allows us to make either servers or clients on TCP or UDP. So we're gonna say localhost 3333, and we're gonna connect with a bunch of them. Right, so this one is going to say hello everyone, and then they're going to disconnect. So if somebody else says hello, everything's going to continue going according to plan. So there's not going to be any problem, everything's going to be fine. Right, so we could write our web servers like this, like we've just seen. However, this is going to prove complicated because there's a bunch of processing once we try to analyze this data. So maybe we could use something which is more web specific. So let's write a simple web server with something which is included with Node, which is a module which is called HTTP. Now this is going to function similarly to what we've just seen. So we're going to say HTTP server is HTTP dot create server. Whilst the socket variant is something we're basically never going to use, this is something we are going to use. We are going to use it because so this is what we've written is a server which does nothing. But then we're going to use this because there are going to be situations where we want to decouple our application logic from the actual server in order to have the same application delivered from multiple servers. Now, why would we want that? Well, I say multiple servers, but it's actually going to be two because we mostly want to have our application be delivered both on HTTP and on HTTPS. That's because some clients are going to connect to us on HTTP. Some of them are going to connect to us on HTTPS. And the advantage of using HTTPS is that we're going to secure the communication. So if there's somebody snooping in the middle of the communication, they're not going to see the traffic. This is important because by default HTTP sends things in clear, right? So it's plain. You can read it, and you can see this with any traffic analysis tool. Now, since we're still on a relatively low abstraction level, the simple HTTP is actually going to handle an event, and this is going to be on request. But the handler is actually going to look a little bit more similar to what we've already seen in Express, and this is going to be something of request and response. Right, this is the typical way of thinking about the web and HTTP servers, which is I have some representation of the request, which is what was requested of me, and some sort of representation of the response, which is a way for me to respond. Right, so on request, now we're actually not going to do something all that complex. So what we're going to have to do is write the head of the message, right? So the response code and whatever headers we want, and the body of the message. So we're gonna say response.writeHead 200, and then we're gonna say, well, we're going to respond with something text plain, and on the web, whenever we have a resource and we're sending it to somebody else, we're responsible to specify its type. And now we can do response right, but we're going to just do response and say got it. And we can actually test this out and relatively simply. If we run this, we don't need a specific client. We can use a specific client, but we don't need it. And if we open a browser, we can just go to HTTP localhost 8080, and we're gonna get got it. However, if we want more complex logic, how would we go about it? Well, we have to manually analyze what was requested of us. How would we do that? Let's just look at the URL. Well, we can use a package called URL, which is also included in our node installation. And let's say parsed is url.parse request.url. And we're just going to write it to the console because we're not going to bother too much with it. And here we should, so in this all-encompassing handler, we will need to handle different kinds of requests. Right? We're gonna have to wonder if that's a post request, a get request, if it has parameters, if it doesn't, if it contains a request body, etc. So if we try to write a web application on this approach, we'll end up inventing our own web framework. Let's just see how this goes. Right. So we get this parse thing. So if we request something like kittens, right? I can see what was requested of me, but there's no obvious way of representing our application logic. So this is not going to do. It's a little bit too low level. So instead, we're going to use Express. So let's see a simple server with Express before anything else. We've actually seen some Express servers, but let's just go through it again, just so we clarify a couple of things. Now, Express wasn't included in our node installation, so we're going to do simple Express. And this application, this micro application, is going to have at least two files. So it's going to have our server file, but it's also going to have a package.json. That's because since we're using an external library, a third-party library, we're going to um, we're going to need to specify our dependencies. That's because if we give our application to a another programmer, they're going to need to restore it to some sort of workable state. So they need the dependency information. So let's just go to simple server, install Express, and take it from there. Now we have this dependency. Anybody having this package JSON can recreate the node modules. So let's go to our server. We're not going to do much actually. So what we're going to do is we're going to import Express, create our app, and our app is only going to answer requests on this combination of method, address. Now each of them is going to be treated by something which looks like this. Again, request response, just like we saw earlier. And we're gonna say response.status 200.send. Okay. And our app is going to listen on port 8080. Now let's just test this simple thing and then talk about what we can actually do in Express. So our server right now, if we request kittens, it's going to say it cannot get kittens. That's because it can only do what we've expressly specified. And if we request the root, it's going to say okay. Now, in order to see what we might do in Express, and Express is just an example, we could do this in various other web frameworks. A bunch of them in whether they're in server-side JavaScript, so Node, or in other languages. The concepts are going to be similar. So what we might do is implement one of two things. So there's two ways of going about this thing. So one of them is to have a multi-page app. Now a multi-page app is going to be fundamentally server-side rendered. And we're going to see this a little bit later today. This is not our focus, but we just want to see a couple of examples. A multi-page app is going to function in the following fashion, which we've discussed when we talked about HTML forms. So I request a page from the server, and what the server gives me, is a page containing a form, basically. And I fill in some data in that form. I press a special button which does something called submit. This is going to take everything that I've entered in the form, package it up in some fashion, and send it to the server. And now the server, based on my data, is going to create in some fashion a new HTML page which is going to be sent to me, so I can fill in another form and so forth. Now, the way the server is going to do this is going to be via template rendering, right? So the server is going to have a bunch of templates, which are going to be, from the perspective of the server, text files. And whenever I request something which is related to a particular template, it's going to read that template as a file. And the template is going to have some holes in it, so to speak, in which to put in dynamically generated data. So based on what I've sent the server, what I've requested, the server is going to take that text file, replace the parts which are dynamic, and then generate an HTML file and give it to me. So that's the classical approach. Now this has a couple of caveats, which is since the HTTP protocol is stateless, I'm going to need some mechanism to maintain state between multiple requests. This approach actually fits a bunch of applications, such as, say, Wikipedia. I wouldn't gain much by representing Wikipedia as something else, right? As a single page app. Now, a single page app is going to function a bit differently. It's actually going to be two different applications. One of them is going to be a service on the server, which in our case is going to be something which is called a Restful Service. And that service is just going to allow somebody to access objects remotely. Now, the service might be used, or as it said, consumed, might be consumed by a console app, by a mobile app. But in our case, it's going to be consumed by an app running in the browser. Now, whether the assets for the app running in the browser are given by the same server or by a different one, what's going to happen is that some dumb content, so not non-interpreted, is going to be delivered to the browser, to the client's browser, and they're going to run a bunch of JavaScript. And that JavaScript is going to function as a browser app, so it's an app running in the browser. It's going to be a single page app, so it's just loaded once, and then that code is going to decide if and when to make subsequent requests to the server, but they're going to be handled from JavaScript. In relation to the idea of state, that application is going to not have any state problems, because it's just going to maintain state in variables, in JavaScript variables, because it's never reloaded and its state is never destroyed, so to speak. Right, so let's build a simple API in Express, which is going to be, like I said, half of this single page app idea. Uh, I'm saying half because it functions as a standalone thing and it can be tested separately. Now, because it can be tested separately, I'm going to be able to isolate it and have a certain amount of certainty that it works without having to integrate it in the full thing, right? I can say my backend works, which is one of the reason that you have something to deliver as an intermediary deliverable. So let's create our simple API, and it's going to be a widget API. Now, what the widget is, it doesn't matter. It's a simple any kind of entity API. So let's create our simple API. So we're gonna again have server.js and package.json. Although we're going to have maybe we're going to have more dependencies here. But first, let's just go to simple API and install Express. Our server, we can actually start from the simple Express server. And I said that we're going to have a bunch of widgets. Now, I said that this service and services like it are going to allow me to access objects remotely. Now, I could have a bunch of models for this. So I could think about this problem in different ways. Right? So the question is, how do I access objects remotely? And in the case of RESTful APIs, RESTful services, the answer is you access them through the HTTP mechanisms without necessarily increasing the vocabulary, right? Without adding anything else. So I said we want to have a widget API. So let's say, so if I want to see a list of all the widgets, it's going to be app get widgets. Now, this is intuitive, but what else would I need? So if I think about just widgets in isolation, what I'm going to need is to at least support the fundamental operations on objects, right? Which are going to be the CRUD operations, so create, read, update, delete. Now this seems like a read, right? How would I go about creating? Well, I'm going to use, and this is a convention. This is the advantage of this is if I just look at the pair of method address and I sort of know how the entities look like, I don't have to look at the code. I can understand how the code works. So creating a widget is going to be done via a post method. Now this makes sense because I can only create something new. I'm not going to be able to create something which already exists. Now, when talking about something which already exists, so if I do get widgets, this might be an empty array. Right? There might be no widgets. But if I want to request a particular widget, I'm going to have to send a parameter to this. So it's going to be get widgets and then a widget ID. Now this is what is called the path parameter, and it's a way in which I can customize what I'm requesting from the server. There are four major ways in which I can do this. So it's path parameters, query parameters, headers, and the request body. And we're going to see them, but step by step. Now this gives me a widget, a particular widget, which means what I might get back is either the widget or some sort of message telling me that the widget does not exist. I might request a widget which does not exist. Now this principle of only being able to get something if it exists also applies to editing. I can't actually edit something which doesn't exist. So this is going to be represented by the put method. Right, so it's going to be put widgets slash widget ID. And again, if this exists, I'm going to try to change it. If it doesn't, I'm going to get some sort of not found message. Now this put is actually something which is called edit by replacement, which means what I'm doing is replacing something existing with a new version of itself. If I need more granularity and I need another kind of editing, I also have a method called patch. Now the last thing from the CRUD list is delete. Again, I might think about delete in different fashions, but uh, the way we're going to represent it is I can't delete something which doesn't exist. Right, so again, it's going to be dependent on widget ID. Now, something which I might wonder is how does the server select which one of these is going to be executed? Well, it actually goes in order through them and sees if the method and address match. And if they don't, it goes further and further on. And if none of them does, it's just going to say it cannot do anything. Now, each of these functions which handle a request are going to need to send some response back to the client. If they don't, if they match, right, if it is the correct method and the correct address, but they don't send anything, they're never going to answer. So the client, the only recourse the client has is to, at some point, get tired of waiting and time out. Right. So let's implement a simple service and use this as an opportunity to explore express mechanisms. So the first question which appears is, where am I going to hold the widgets? Now, in the end, what I'm going to do is I'm going to store them in some sort of database of some sort, but not for today. So for today, we might hold them in a variable, right? So we're going to say const widgets is this. Now this is fine as long as my server is one file. If it's multiple files, this is not actually going to be the server state. It's going to be the module state, right? So this is going to prove insufficient. So what I might do to keep server state is I could use something which is called app.locals. Now the advantage of doing this is I can get app locals from response. So I can say response.app.locals and get it wherever I am. Now this app locals widgets array, which I'm going to populate with something, let me just find some a minimal amount of data. Right, so they have an ID and a description. Now this, if I add something to this array, which I can, it's not actually going to persist if I close the server and restart it. It's always going to start in this state. Now this is the problem with having volatile state, but for now this is going to be sufficient. Now let's implement our endpoints and see what problems each of them is going to give us and how we're going to test them and so forth. So for the first one, get all the widgets. Now this is actually just going to say res status 200, which is a success, JSON, and it's going to be app locals widgets. And we can already test this out. We're going to we can start our server with node 1 and test it. We're just going to test everything later though. Okay, what happens if I post something? Well, if I post something, so this time I noticed that I had the widgets, right? The server has the widgets and it delivers them to the client. And also, since I use this JSON, it's going to specify that they're in JSON format. Now, when I said that in whatever fashion the server has to respond something to the client, uh, it, there's multiple ways of doing this. Ultimately, it's going to be a response.send. But response.send is accompanied by a bunch of methods which just make our life easier, right? So they're quality of life methods, such as JSON, right? I could have done this manually, so set the header manually, serialize that array to string manually, and just send it. I could have done this, but it's a lot more comfortable to just say .json. Now, if something is posted to me, the reverse of the situation appears, right? Because I don't have the widget that's supposed to be added. The client has it. And the client should send me the widget and they should send me the type of the thing they've sent, right? So they should send me a content type and some sort of payload. Um, Now, where are they going to send it to me? Well, typically they're going to send it in the request body. So I might suspect that I have a request body, so I'm going to say const widget is request.body. And then to add it, I'm just going to app locals push widget. And then I would respond with something. Now I can respond either with the thing that I've just added. I'm going to use a response code of 201. It doesn't really matter, but this is typically conventionally used as create. What matters is the class of response code I use, which is a 200 something. I could respond just with a message that everything happened correctly. So I'm going to do that thing. So JSON message created. Right, and I could test this out and it's not going to work. Now, the reason why it's not going to work is that I don't actually have request body. It doesn't contain anything. So there has to be something to populate it. And what is going to populate it is something which is called a middleware. Now, what a middleware is going to be is a function which is going to to either modify the request or modify the response, and then pass control further on. Now, something which has to be noted is that in fact all of these are also middleware. But before doing that, let's just write the simplest middleware and see what it might do, and just call this one. This one is going to work either way. So our simplest middleware is going to be a logging middleware, something which says this was requested. The way to apply a middleware is via a method which is called app.use. And this receives a function, which is a function of request, response, and next. Now request and response, of course, because we want to read what was requested of us. Response, because we want to be able, even if we don't do it, to respond to the client directly. Now, when would I want to do that? Well, let's just think of a middleware which handles authorization. Right? So I'm trying to access a resource, and this particular middleware checks if I have the requirements for accessing that resource. Maybe I know a secret, maybe I have a permission somewhere, it doesn't matter. And if I don't meet the requirements, the middleware is not even going to go to the resource. It's going to reply to me directly and just tell me I'm not authorized. Now in our case, we're not going to use that. What we're going to do is we're going to log request, let's say requested request.url. And if I stop here, this is never going to answer the client, right? Because it doesn't have any response.send. Now if I do response.send or response.json or whatnot, I'm never going to go further. So what I have to do is either answer the client or call next, which is a function. Now if I look at this, it doesn't specify any method, it doesn't specify any address, which means it actually applies to everything. Now this applies to everything, and after it does its logic, which is this line 14, it's just going to pass control further, which means the server, which processes these in order, is going to continue searching for something else to apply to that request. In this case, get widgets. After get widgets does respond, the server is going to stop looking for other things. So let's just see this in action. So this cannot get. That's because our server only knows how to do what we've explicitly told it to do. So widgets, and I get my widgets. Okay, if I look in the console for the server, I can see slash was requested and widgets was requested. So that's what the middleware does. Now, what does this have to do with our post endpoint? Well, we're going to need somebody, one of these middleware, to actually populate request.body. And this is called a body parser. And it can be applied just like any other middleware. Body parser is actually a collection of factory functions. So what I can put in app.use is something of request, response, and next. And I'm going to get that from body parser .json. And it's a factory function. It's something which returns another function. So now my post is going to actually work. Now what about these things? Well, I can see that this has a this sort of marker here. Now what this refers to is it applies to any request which looks like this. So it's a /widget /5 as well as /widget /10 as well as /widget /something. And I can get these from something which is called request.params. This is a request parameter. So I'm going to say const id is request params id. Now this is not going to have the expected outcome, because if I want to compare this ID with these IDs, I'm going to have a problem, because the protocol is text-based. So what I have on the right hand side of this equals is a string. So I'm not going to be able to compare it to a number. So I can say parseInt of this thing. And now I am going to be able to compare it. Now let's look for our requested widget. So we're going to say widget is app locals widgets find for e.id equals ID. I'm in one of two cases. One of them, the widget exists. If it does, I'm going to send it to the client. Second one, the widget doesn't exist. And then we're going to send a message to the client. This is going to be an error, but it's going to be a client-side error. Typically, it's 404. Now, this sort of logic, which checks if the thing I'm trying to operate on exists, is going to be applicable to both put and delete. Now, for put, again, I'm just going to copy paste this and modify it. So for put, the fact that I found a widget is not really all that useful. What I want to find is the widget index. Now, this is going to mean that this particular condition is not correct. So what I have to remember that the widget index is actually, which I'm going to get from find index, is actually either going to be a position or -1, just like for index of. So if it's not equal to -1, then I'm going to send the to operate on the widget, which means app locals widgets of widget index. And let's say the only thing we can modify is description, and we can get the description from request body description. And then we're going to just communicate that everything went correctly. So we're going to say, we're going to change the code to 202, right, which is going to be accepted. As for delete, well, it's going to be really similar to put, which means we can just copy paste it and just again we have to check if everything we assume exists does indeed exist. And if it does, instead of editing it, we're going to delete it, and we can delete it with splice. So from widget index 1 position. And that sort of wraps up our fundamental operations on an object. Let's just test it out first, and then explore this a bit further. So we're going to be able to test this out from a browser, and we've seen this, as well as this one. However, for all other things, we need some sort of mechanism to create our own HTTP request by hand. We could use a command line tool such as curl, but that would be a bit too difficult, so let's look at Postman, right, which we've previously used. So if I want to request everything, I'm just going to go to localhost 8080/widgets, and I get my widgets. If I want to add a widget, it's going to be the same address, but it's going to be the post method. And as we've discussed, I'm going to have to both send the widget to the server and specify its type. Which means for the type, I'm going to write a header, which is going to be content type. And in this case, we're going to send it in JSON format. And in the body, I'm going to go to raw, and we're just going to write a widget. So it's going to be ID is 3, and description added widget. And this didn't work because we've forgotten something. It's app locals widgets push, and it says created. Now if we check up on our widgets now, we can see that we have a third widget. Now if we get the the first widget, we can write something like this. This is going to mean that in the request params object, I'm going to have a key called ID with the value 1. Now since this widget exists, we can do something else, which is we can modify it. So this is going to be a put to localhost widgets 1. The header is going to be content type application JSON. Now I do have to specify this because, just like for post, if I do edit by replacement, I'm going to have to send what the entity is supposed to be replaced with. And here we actually know that we only need description, and we're gonna say modified widget. Right, it said accepted, which means that if we do the get again, we're gonna say that the description was modified. As for delete, I'm going to have the same address. Now for delete, I don't have to send any headers. I don't have to send any request body. I just have to specify the ID in which I'm trying to delete. It says accepted. So now if I request the widget with ID 1, I'm going to get not found because it's no longer there. Right? It's been deleted. Right. So let's explore a couple more things. Now, if I look at my source, this is all fine. But obviously, if we keep adding this list of possible requests that can be performed on our app, this file is going to start getting larger and larger. So we might want to group it up somehow, right? To be able to put this in an external, to put widget related things in an external module. That's one thing we want to take into account. Now the second thing is we've said that we can parameterize our request to the server via request parameters, but also query parameters. So we've seen request parameters and request body. Headers we're going to somewhat leave for later, but how would query parameters work? Well, for query parameters, we're going to consider the following thing. So if I request all the widgets, this is the list of widgets is a resource, right? It's a distinct resource. If I request widget-id, this is another distinct resource. Now, one sec. Right, so what I'm requesting here is a particular resource, so both here and here. But what if we, instead of requesting a particular resource, what I want to request is a particular representation of a resource. So for example, if I want the widgets to be sorted, or if I want them to be filtered, or if I want them to be represented as XML, it's the same resource in a different representation. Now, because it's the same resource, it's not involved in the matching, right? But so get widgets without a query parameter is the same for route matching as get widgets with query parameters. So what we want to do is, let's put a comment here. We want to do something like get widgets. And now query parameters are going to be just like query parameters in URLs. So the list is going to start with a question mark. And we're going to say simplified equals 1. And they're going to be a list of key value pairs separated by ampersand. So what effect could this have? So for the simplified representation, let's say we want to get only the descriptions of the widgets. So I'm going to wonder if request query simplified equals 1. Now this isn't going to work out, so we're going to parse int this. So if it's simplified, we're going to send something. Otherwise, we're just going to send what we were sending before. So if it is simplified, we're gonna say we're gonna send this, but instead of the widgets, we're gonna map the widgets to their descriptions. Right, so let's check this out. So if we request widgets, same thing, but if we do simplified one, we get only the descriptions. Right, so on to the next thing. So it's like I said, we might want to put this in a different file. Now let's see how we'd go about that. So we're gonna create a file which is going to be called Widget Router. And first we're going to take all this code and move it. Right, so all the widget related things. Now first let's handle the router. So for now, all the references are to app. Now app isn't going to exist here, so let's first import express. And then let's create a router. So I'm going to say const router is express.router. Now our export from this module is going to be router. Now obviously these are not valid, so instead of router of app.get, I'm gonna have a router.everything. Something else to take into account is that this app.locals thing doesn't make sense. However, we can do response.app.locals, which is the reason why we've used app.locals anyway. I hope I'm going to find all of them. If I don't, we'll correct it. Right. Now, our server, though, doesn't make any reference to the router. So let's see something. Let's see how this would work. So first, we're going to import the corresponding module. We've required the widget router, and now what we're going to do is use it on a particular URL path. So I'm going to say app.use, and here, first of all, I noticed that this is another middleware actually. The second thing is I'm going to use it on Widget API. So I can apply middleware on a particular set of addresses, right? On a particular partial route. Now, assuming everything restarted correctly, I can no longer do get widgets. However, I've moved it. So I can do get widget API.widgets. And of course, I can separate this into different buckets. Now, why would I want that? Well, on the one hand, I just want to organize my code. On the other, I'm probably going to have different areas of my application with different conditions. So for example, I might have a router for registration. Now, since this is a router for registration, anybody can access it. Right? They can access it because otherwise they wouldn't be able to register. But, for example, I'm going to have another router for users. And users can only perform operations if they're logged in. So if they've demonstrated that indeed they are users. I might have another router for admin. So there's some subset of the operations which cannot be performed by regular users, but only by special users, and so forth. So I want to group all this stuff together. Right. Now, something to take into account is that I can actually apply middleware to the router, and I can also apply middleware to a particular line, so to a particular app.get, for example. Now let's see that in action. So first let's have a middleware. Let's say it's a ping middleware. Again, function of request, response, and next. And it says in the console, I have been pinged. Now let's also have an endpoint here. So a combination of let's have a combination of method and address, which is going to say be ping, and it just says pong. Now what we want to do is have this ping middleware apply just to this particular request. So we can actually write it like this. And instead of one middleware here, I can also have an array of middleware, which are all going to apply in order. So let's see what happens. So now, if I request the widgets, I'm going to see that I have the requested logger writing it, but I don't have anything ping related. But if I request ping, I'm actually going to have both the request logger, requested slash ping, and also the ping logger. Right, so middleware are processed in order. They can respond directly to the user, or they can pass control further on. There's also something else, which is we have something which is called error handling middleware. It's a special kind of middleware which is going to be at the end of our little processing chain. Now, an error handling middleware is going to handle the following situation. Let's consider that we have a an address and we can get something which is slash error, and this is something of request response for now, and I can get an error here. So let's have it have a query parameter which is a trigger. So if request query trigger equals on something, otherwise something else. So if I don't trigger the error, I'm going to say response status 200 send no error. But if I do, now what's going to happen, maybe there's complex logic here. What's going to happen is I'm going to have an exception from. So I'm going to say throw new error of some error. Now, if I leave it as it is here, I'm going to have a problem. So if I trigger it, there's nobody catching this, and there's nobody answering the client. So again, timeout. In order to catch this, let's just have a try catch. Now, here we might have some logging logic, which is simplified here, but it might be more complex. So I might have a logging server, or I might just log into system logs. It doesn't really matter. And it's an error which the client can do nothing about. So we're gonna say message some server error. Now imagine there's a bunch of these. Right? Now if there's a bunch of these, this sort of error logic. If there's a bunch of these, and for example, at some point I decide to have more robust logging. So I want to have a logging server, and whenever there's an error, I want to make a request to that logging server and log the error. Now, if I decide to change anything, I'm going to have to edit it in a million places. Instead, what I might do is notice something else. So first off, I said that in fact, all of these, so get ping, get error, all the gets for the widget, posts for the widget, etc., are actually middleware. So they look like this. So instead of doing what I've done here, I might want to pass control if there's an error. Now pass control to who? Well, there's going to be a middleware which is going to be at the end, or multiple middleware of the same form. So app.use, and they're going to look a bit different. So they're going to be something of error, request, response, and next. And I can have my error logic here. So if I want to change it, or if I want to have a different kind of logging, or if I want to have different kinds of errors treated differently, I'm just going to write in a single place. So let's see that. So if I go to error, no error. But if I trigger it, okay, get error, okay. If I trigger it, why did it say cannot get? Let's see. One sec. One sec. Let me just pause. Right. So the problem is that whenever I do next to a error handling middleware, I should do this. So it's next of error. Right. So now if I trigger the error, so it's off, it doesn't matter, but on, if I trigger the error, it says some server error, and I can see the log for the error here, which may be treated like this, or it might be something more complex. For example, I might use something like monolog, which is a logging library, to have more complex logic, to write it in multiple places at the same time, to have rotating logs and so forth. Right, so this I think about handles our discussion about Express at this point. Something which we've not seen is using headers. Now I can get headers from request.headers. I'm going to pause this for a bit and take questions. Now we're going to write a bunch more services next time and later on. However, I'd like us to look over classic applications for a bit. Now there's two things which interest us. So for this first thing is we want to see how a templating mechanism works and how state is maintained between requests. And we're going to see this on a really simple example. Now for the second thing, the second thing is let's say the general flow, which is the form-based flow of an application, and we're going to see that pastebin clone we've been using at the tutorials if we have. So it's something which sort of works like pastebin, and we're going to go through that. Now, first things first, let's create a new folder here. It's going to be called Simple Classic. And we're going to have a server.js and a package.json. Obviously, one dependency is going to be Express. We're going to use Express for this as well. But we're going to have at least one more because, like I said, for a classic application, we're going to need some sort of templating engine, right? Something which is going to allow the server to render HTML. And we're actually going to use two different templating engines in our two different examples. just to see. You can use a bunch of them. There's a list of them, and there are a lot of ways of writing these things in Express, right? Which are a lot of templating engines which are can be used in Express, but not necessarily in Express. I can use them in other contexts as well. Now, these files, which are going to serve as the template, are typically in a folder called views. I can configure this, but if I don't configure anything, it's going to be in views. Now back to our server. So we might start from something like Simple Express, right? So it's going to start up like this. However, I need a couple additional things. So first, I might want to specify the view engine, and for now we're going to use a view engine called Pug. Now this is a dependency and it has to be installed, and it refers to files which have the extension pug. Right, so I'm going to have an index pug and the next pub. Now, what the server is no longer going to do what this one did. Whenever the root is requested, what the server is going to do something else, which is response.render. Now, what render means is the server is going to read the file and then select a view to render. And let's just do it like this. Now, if there was no data that the server wanted to add to that view, there was no point to this, right? It was just static content. So typically, what I want to do is render it with some parameters. And let's see what our parameters could be. So let's say we have these parameters. This is going to be a list of key value pairs. Right, so I'm going to render it with some title and some message. Now, how is this going to work in index.pog? Now, fair word of warning, this is actually a bit stranger in the sense that pug, we're going to see a rendering engine which looks like HTML further on, but for now, pug actually looks like Python. So it uses indentation as blocks, right? So I can do this, so I can do this, okay, and I can have body, etc. And let's say I can have an h1 and the link, etc. Now if I do title some title, the title is actually going to be some title. But if I do something like title equals, I can actually use one of these keys. So h1 equals message. And let's see if this works up until this point, and then we'll add the other part. So we need express and we need pug. There's no point in reloading the server because we're going to want to install something else. So if I go to index, which is the root, I have a page with some title and some message. Right. Now let's look over the second thing, which is we want to maintain state between requests. Now the way to do this is using sessions in this case. So I can maintain state either via cookies or via sessions. Now cookies means that the whole state is saved on the client. Session means just a state key is saved on the client. And the client is responsible to send in a header that key with every request. Now, in our case, we're going to have express session. Let's say session require express session. This is also intuitively going to work like a middleware. So I'm going to say use session of some sort of session password. Now I can actually get get the session object from the request. So I'm gonna say const session, and if I get it, I can actually do some session data. Now, if I think about index, it's not really all that relevant, but let's have index navigate to a different file. So first of all, this is going to we're going to have a link in index. Right, so this is going to be a link. All right, so it's a href next one. Now, if I go to next, I don't actually have anything there, so the server is not going to know what to do. So app.get/next going to be something of request and response. And the trick here is that I can get the session again, and that session.someData exists, which means I can now render next with a data is with data, right? So it's the key is data and the value is data. So if we go to next, we can have an HTML here which contains a body, which contains a p, which is going to be data. Now we're going to install express session. And if we now go to the root of the server, I get the same thing, but I have a link, and I can see that the session data persisted between requests. Right, so that's the state mechanism. Now the second thing we want to look at is the general flow of the thing. So what we're looking at is the space bin. We're just going to omit all the styles. So we have this, right? This actually exists, and we use it to pass code around for our seminars. Right. So we have this toy application, so to speak, right? It's something. Let's just see. So we can do this. We can copy paste everything, and it gives us, I can give you this link, and you can access it, and it's the same thing. Now, what's deployed on the server at this point is persistent, but what was initially deployed was not persistent. It had volatile storage. It's the equivalent of this message will self-destruct in a half an hour. So let's write that. Although we're not going to go into the styles, although I'm going to make the source available to you and you can look over them. They're done with a library which is called Highlight.js. So I've not done this manually or anything. Right. So let's create let's call it repaste. And since it's actually worse than what's deployed, we're gonna call it 0.5. So let's go to repaste and see how it would work. So first things first, we're going to need our server before anything else. Nope. Right, we're also going to need a package JSON. Right. We're also going to need some sort of templating engine because it's a one of these classical applications, right? So our this time it's going to be something which is called EJS, and this actually looks more like HTML. And let's see what our endpoints are and our views are going to be. So given a folder which is called views, which let's say contains a subfolder which is called pages, I'm going to have an index.ajs, and I'm going to have a paste.tjs, and I'm going to have I might request a paste which doesn't exist, right? So it's going to be 404.tjs, although we're not going to write much in it. We're just going to write nothing here. Now, how about our endpoints? Well, we can get the root. We can paste the paste. We can post the paste. We can get the paste. And this is not really obvious, but we probably want to be able to get a raw paste. That's because in the actual application which functions. If I look at this and I go here, this bit isn't actually text, it's HTML. So if I try to copy this manually, it's not going to copy all right. All right, so I can go to raw, so I have something which is copy pastable, or I can press the copy button and so forth, but I can actually select the text manually and copy paste it because I'm going to paste a bunch of divs. Right, so I'm probably going to need something which does this. So paste slash raw slash ID. I'm going to listen to a port. And now before we continue, let's uh, let's think about how these would look, and then we're going to write the whole thing afterwards. So for index.js, what I'm going to want is to have a form which allows me to create a paste, which means it's going to look something like this. I'm going to just copy paste it here. Let's see. So minimally, this is the part which is relevant. I'm going to have a form which has a method post and an action which is pastes. So this is going to post to paste whatever's in the form. Now, whatever's in the form is going to be pasted when I press submit. And what's in the form is a text area which has the name content. Now, the second question is, how is this going to be sent to the server? It's actually going to be sent by default URL encoded, which means it's going to be transformed into a list of key value pairs, really similar to what we've seen when we talked about query parameters. Only instead of being in the URL, in this case, it's going to be in the body. But last time we played around with request body, we needed something to interpret this, right? We needed body parser.json. Again, we can use body parser again because body parser isn't actually just something JSON related. It handles a bunch of encodings. And in this case, we're going to say app.use body parser.url encoded. Let me just check this out. Yes, because, right? URL encoded, extended, true. Right, so that sort of handles this one. What about pasty.js? Well, what I'm expecting to have happen here is to get a to have a and notice that my EJS actually is in HTML in this case. There's nothing in it. What about pasty.js? Well, this is not just an HTML, is it? Because in order for it to be rendered correctly, it has to have the paste and maybe something else, which is the key of the paste. But before that, let's think about it for a bit. How are we going to store these pastes? Well, since it's volatile, we might store them in a memory cache. Now, our memory cache might look like an object with the particular characteristic that after a while, keys in this object expire. So let's handle this. We're going to use something which is called node cache. Again, this is going to have to be required, and we can actually create a paste cache, which is going to look like this, which says node cache where the time to live is half an hour and the expiry is checked each 120 seconds. Right? So 1800 seconds, 120 seconds. Right, so something else. So the keys. How are you going to get the keys? Well, if we look at our form, we're not letting the user specify their key because we're going to have a bunch of conflicts. So one way of using the keys is to generate some keys which are unique. And we're actually going to use something which is a unique identifier, UUID. Right, so we're going to go back to pasty.js shortly. So first here we're going to say response.render index. There's nothing to add for index. Actually, it's in view, so it's pages.index. Um, there's nothing to add for index. It's fine as it is. Now, what about post? Well, when we're getting that, we're getting like I said, the body parser is applied, which means we're getting in, if we look here, in a key called content, we're getting the paste. So first things first, we're gonna say const paste key is UID, unique identifier. Then we're gonna say paste cache dot set paste key and request dot body dot content. And after that, we might respond with something, but what we want to do is go to the page viewing this particular paste. So I'm gonna say response redirect pages slash. Well, we need something more, right? It's we need to be able to refer to that particular. No, it's not pages slash paste. Sorry, it's paste. It's paste slash a particular key. So let's do that. So it's paste slash paste key. Right, so we can no longer avoid this. Let's go to paste.js where we're going to get, so typically if we look at this, it's ultimately going to be a render, right? It's going to do render for paste.js. Let's see how that would look actually. We're gonna say const key is request params key. Const paste is paste cache dot get key. Now we might have the paste or we might not have the paste. If we don't, we're gonna say response dot status 404 render 404. If we do have the paste, we're gonna say response render. Well, it's going to be something. It's going to be pages slash paste. It's called paste. Sorry, paste. And we need to give it a couple of parameters. So we're gonna say the parameters are the paste and the key. Maybe we need that. Right. So if I go to paste EJS, I'm going to have something which is going to look like this. Now I can see how EJS works, right? Because in EJS, this is a regular HTML. It's just that in some points I have this sort of structure. So it's less than percent equal something which comes which have been injected by the server, and then I can close it with percent greater than. Now this is a link to a raw paste. This is a link to home, and this is the paste itself. Which means if I go here, this should work. What's missing is the raw paste. Now for the raw paste, we just want to send something which is text plain. So we can sort of copy paste this. This branch with render and so forth is fine, but this branch is not fine. So instead of doing that, what we're going to do is response status 200. Now, like I said, we want to ensure that this is going to be text plain, which means we're going to set a header. We can do that with set. And then we're just going to send the paste. That's it. Let's just check it out and see if it works. It's not this one. I think it's something else that's running. I think we have a bunch of stuff to install. Let's see what else is missing. Oh, Express. Alright, and what else? Oh, DGS. Right, so now we should see our thing. It's the style is missing. So let's just take our server code and share it through our server. Cannot post pastes. Okay, let's see what's wrong here. Right, that's because it's pastes. Right, found undefined. Now let's see what happens here. Paste key. That's not how to get a UID, maybe. Maybe. UID v4. Let's see. No, I think it's from the redirect. So it's paste cache.get. one sec. We're going to find what's wrong with it shortly. Oh, it's we said key here, and it's actually key everywhere. It's key and key. Right. So let's just try this again. Right. So this works, and if we go here, this works. And that's our paste. I'm going to stop the recording and take any remaining questions.